On page 19 and 20 of our Unit 2 notes, we're looking at a new form of a linear equation called point-slope form. The form that we have been working to up to this point is called slope-intercept form, and that is the form y equals mx plus b. It's called slope-intercept form because it's written with the slope as the coefficient in front of x plus the y-intercept. This new form, point-slope form, is so named because it still has the slope, but it also includes one particular point, x1, y1, that falls on that line. In this example, we are subtracting x1, meaning x1 is 4, so minus 4, and we are subtracting y1, so y1 is 1. That means the point that I'm given from this equation is the point 4, 1, and I can go ahead and plot that. Again, I'm subtracting the x value and subtracting the y value. That means my x is positive 4 and my y is positive 1. Then I still just find the slope right there in front of the parentheses. So my slope is just negative 1/2. I'm going to put the negative with the 1. So my rise is negative 1. My run is 2. I'm going to go down 1 over 2. That's the only point that I can plot traditionally, down 1 over 2. So then I need to go backwards, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2, and so on. Now, I did not leave space for this on the notes, but we did this in class. I can very easily transform point-slope into slope-intercept form, and that's a really good idea because then I can check my line, which of course should have a straight line with arrows. So I'm going to check that by transforming my point-slope into slope-intercept. The steps are always the same. I distribute the slope, so I have negative 1/2 x, and then I do negative 1/2 times negative 4, which gives me positive 2. So I distribute, and then I add that y1. So I don't really have room for this, but my slope-intercept form of this equation is y equals negative 1/2 x plus 3. And then I can check my graph, and look, I was correct. I have a y-intercept of 3 and a slope of negative 1/2. If I'm instead of given the equation and asked for the point and the slope, if I'm given the point and the slope, I'm going to just subtract that x value and that y value within my point-slope form. So y1 is negative 5. That means I could write y minus negative 5, but that is not very sophisticated looking. I'm going to write y plus 5 equals m, the slope, times x minus x1 times x minus 2. This is the point-slope form of that equation. I could again write it in slope-intercept form, distributing the negative 3, subtracting 5, and I would get y equals negative 3x plus 6 minus 5 plus 1. Another example, my fraction bar is messed up. My x1 is negative 3. My y1 is 6. So my point-slope form will be y minus 6 equals, that looks like positive 2/3 x minus negative 3. And that is where I'm going to change it to x plus 3. Just looking at that equation, I know my x value is going to be the opposite of positive 3. It's going to be negative 3. The opposite of negative 6, positive 6. Let's do one more example. How about this one? The point is going to be the opposite of this number, so positive 1 for my x, and then the opposite of this number, negative 4 for my y. And then my slope is just here, 2. So to graph from point-slope form, I graph that point, 1, negative 4, and then I use my slope, rise over run, up 2 over 1, up 2 over 1, up 2 over 1, backwards, down 2, left 1. I can transform that equation to check my graph. 2x minus 2. Subtracting 4 from both sides, I get 2x minus 6. And hooray, I'm correct. The y-intercept is, in fact, negative 6. And again, all of these graphs should have a straight line with arrows.